Limits. Now let us understand what limit is. Let us say x tends to 0. That is, x is never 0. X is not equal to 0, but x can be like this, minus 0.00000001, or x can be 0.0000001, which can be taken as 0, which can be taken as 0. Now, this is basically your 0. This point is, this one, and this point somewhere here, it is this one. So, this is called 0 plus the right side of 0. 0 plus the right side of 0, right side of 0, and this is 0 minus this side, and this is called left side of 0, left side of 0. Now let us take a negative number, minus 2. This side is called minus 2 plus, that is the right side of, right side of, right side of, right side of minus 2. And this is minus 2 minus this, don't make it plus 2. This is basically, this is on the superscript. ये ऊपर लिखा हुआ है, ये ऊपर लिखा हुआ है प्लस और माइनस, तो इनको राइट और लेफ्ट समझना है. This is left side of, left side, wait a minute, left side of, left side of, left side of minus 2. I hope now you've understood this point. This is what exactly x tends to 0 means, and the right side and the left side. Let us now come to the definitions of limit. The first one, let us come to this definition. Let me draw a line. Yes, and now let us start from here. The first point. See, limit x tending to a fx should be equal to L. That means this means two things. This means two things. The first is the right hand limit. The right hand limit, that is limit x tending to a plus fx. Let us say this gives me value L1. This can also be written as limit h tending to 0 f a plus h, and this is also L1. Either you write this way or you write this way. And this is your right hand limit. Now the left hand limit is written as limit x tending to a minus fx, that is the left side of a, equal to say L2. This can also be written as limit, let me take some space, this can be written as, this can be written as this, yes, this can be written as limit h tending to 0 f a plus minus h, and this is also L2. Now if L2 equal to L1, L2 equal to L1, let us say, then let us call it L, then limit exists, then limit x tending to a fx equal to L exist. That is, this point is a, this is the right side of a plus, a is any point, and this is the left side, a minus on the top. This is one definition. Now suppose this is, they both are not equal. Suppose this L1 is not equal to L2, then limit L1 not equal to L2, then also both ways it is actually, both ways, that is limit x tending to a, limit x tending to a fx does not exist. Let us take some examples and let us do it. See, take one example. Let us now see. Let us take examples and do this way. Let me take limit x tending to a. Let me take limit x tending to some number. Let us take some number. Let's tending to 2, 3x plus 4. So let us find out the limit. So limit x tending to 2 plus, that is the right hand limit. You must write right hand limit, RHL, fx, that is equal to limit x tending to 2 plus 3x plus 4, बस इसकी वैल्यू यहाँ पे पुट करो, जस्ट पुट द वैल्यू ऑफ दिस हियर, दिस विल बिकम 3 into 2, 3 into 2, 3 into 2 plus 4, and that is 6 plus 4, and that is 10. Now let us see limit LHL. Now limit x tending to 2 minus, that is the left side, fx is equal to limit x tending to 2 minus 3x plus 4, and this is equal to, put this 2 here. No, don't put minus 2, it's 2. It is the right left side of 2, and this is the right side of 2. This is the left side of 2. ये left है 2 का, ये right है 2 का. 3 into 2 is 6. 6 plus 4, 10. So both these limits are same. Now we will have to write like this. We will have to write like this. Now we will have to write like this. Limit x tending to 2 plus fx is equal to 10 equal to limit x tending to 2 minus x tending to 2 minus fx. So limit x tending to 2 fx equal to 10 exists. Rather, I should say, first you write this line, limit fx x tending to 2 fx exists, and limit x tending to 2 fx is equal to 10. This is the way. Let me take another example. Let's take this. Limit x tending to 0 mod x upon x. Now you know what is mod x. This is the question. Now see how to write. Now let us take RHL. Limit x tending to 0 plus mod x upon x. Mod x upon x. So you know what mod function is. You already have discussed all the functions. X greater than equal to 0 and minus x for x less than 0. For greater than 0, you have to take this function. So limit x tending to 0 plus, you take x upon x, and this becomes what? This becomes your, this cancels out, this comes out to be 1. Now let's take limit LHL. We take LHL, left hand limit. Limit x tending to 0 minus mod x upon x. In this case, in the negative case, negative part, we take minus x, this one. So I'll get minus x upon x. They cancel out and I get minus 1. So both the limits are not same. Since, see here, limit x tending to 0 plus fx is not equal, is equal to, plus is how much, equal to 1, which is not equal to minus 1, which is actually limit x tending to 0 minus fx. So limit x tending to 0 mod x upon x does not exist. Next, let us take more examples on this. Let us now take more examples. Let me take question. Limit x tending to 3, take the greatest integer function this way. Now I told you this is the floor function. I hope you remember the floor function. That's why I told you about 4. Take the point 3 here, take a point 2 here, and take a point 4 here. So this is more than 3. Between 3 and 4, it will come to 3. Between 3 and 2, it will come to 2. See, now start. LHL. That's why I taught you all the graphs. This is the reason why I taught you all the graphs. Now limit x tending to, this is here, x 3 minus mod x, sorry, the floor function x, this is equal to limit h tending to 0, 3 minus h, and 3 less than 3, and if it is becomes less than 3, h is always greater than 0, very small quantity. Keep this thing in your mind. H is always greater than 0 and a small quantity. H is never 0. H is never less than 0. H is always greater than 0 and a very small quantity, very near to 0. सो तीन और ये एज जो होता है वो 0 से बड़ा होता है हर समय और बहुत छोटा क्वांटिटी होता है. 3 से उसको माइनस करोगे तो 3 और 2 के बीच में आएगा. ये फ्लोर फंक्शन है. सो इट द आंसर विल बी 2. नाउ टेक RHL. See, I have taken 3 plus, I have written it a plus h wala format mein. I have written in the a plus a minus h format, and then this h is always greater than 0 however small it is, and 3 minus h, so it will come to the floor. It is between 3 and 2, so it will, being a floor function, it will come to 2, so the answer is 2 here. Now here we come, see, here we come with RHL. Now limit x tending to 3 plus floor function, you will have limit h tending to 0, 3 plus h. Now 3 plus h is something more than 3 but less than 4, because h is a very small quantity. So it will come on this floor 3. देखो 3 h is h बहुत छोटा क्वांटिटी है, 3 प्लस h है, तो 3 प्लस h 4 और 3 के बीच में लाई करेगा, ये फ्लोर फंक्शन है इसलिए 3 आएगा, दोनों लिमिट सेम नहीं है। यहाँ पे लिखोगे you will write this way, you will write this way, you will write this way, limit x tending to 3 plus this is not equal to limit x tending to 3 minus floor function. So limit x tending to 3 fx, this floor function does not exist, does not exist, exist नहीं करता। इसीलिए मैंने सब ग्राफ बढ़ाया था, क्योंकि ग्राफ में क्यों कैसे आता है वो क्लियर हो जाता है। इट टुक टाइम, वो ग्राफ हो टाइम लिया, परंतु उसने अब इसका मदद हमको यहाँ मिलेगा, विल गेट द हेल्प ऑफ दिस। नाउ अंडरस्टैंड द क्लासिकल डेफिनेशन, द फॉर्मल डेफिनेशन आई शुड से, formal or classical definition. Formal definition. This says a function fx is said to have a limit L as x approaches, x tends to approaches a, tends to a, wait a minute, tends to a if and only if for any given epsilon, for any given, this is given to you, given epsilon greater than 0, there exists, this is the symbol of there exists, this means there exists in maths. Those who are coming from non-maths background understand this. There exists, this is there exists a delta greater than 0 such that delta gets such that wait a minute, such that such that such that such that such that such that fx minus L is less than epsilon whenever x minus a is less than delta. Let me write this. This is called epsilon. This is a Greek word. This is I'm doing for non-math students. Epsilon, and pronounce, this is a Greek word, pronounced as epsilon, and this quantity is almost tends to 0, almost, and this is called the small delta. See, this is the big capital delta in Greek. Delta. Wait a minute. This is the small letter delta in Greek, and this also tends to 0, very small quantity. Now this you can keep in some other color, don't write, this is for you guys. ये मैं उसके लिए लिखा हूँ जिनके पास मैथ्स नहीं था 11th 12th में, ये रहा. Now this is the classical definition. How to use this classical definition? See, I'll use it for you. कैसे इसको यूज करना है. मुझे एक एप्सिलॉन दिया हुआ है और मुझे एक डेल्टा ढूंढ के निकालना है कि डेल्टा और एप्सिलॉन के बीच में क्या रिलेशन है. सी, given epsilon, I have been given epsilon, I have to find a delta and I have to see how this delta is related to this epsilon. That's the main idea. That's the main idea behind this point. Okay, now let's have some examples on this. Let us have some examples on this quickly. See, let me take one example, a question. Oh, sorry. Let me take a question like this. I have to show that. Whenever they use the word show that or evaluate, you can use this definition. Fx, show that limit x tending to 1, 3x plus 1 equal to 4. I know that 1, if I put 1 here, अगर मैं यहाँ पे 1 put करता हूँ, automatic 4 आता है. अब देखते जाओ कैसे इस formal definition को use करते हैं. Answer, how to write? First write fx minus L is less than epsilon whenever whenever x minus a is less than delta. First write this formula, पहले ये formula ले लिखो, less than delta. एक second. Now compare with uh, compare with this equation. Compare with this equation. In rough, you do this. This you do in rough. Compare with this equation. Limit x tends to a fx equal to L. कंपेयर करो इस इक्वेशन को, कंपेयर करो यहाँ पे, तो देखो एफ एक्स क्या है, व्हाट इज योर एफ एक्स, एफ एक्स क्या है, थ्री, व्हाट इज योर एफ एक्स, 3x+1, व्हाट इज योर एल, कंपेयर हियर विद हियर, it is 4, compare a, this a with this, so your a is basically 1. This is the way, fx is this, l is this, and a is this, no problem. Now just write down these values, this value of fx, this value of L, and this value of A at right here, right here, and right here. Now let's come down. See, I will be keeping this thing here. Now see. Now fx is 3x+1 minus 4 is less than epsilon whenever x, a, what is a? 1, x minus 1 is less than delta. Now wait, I have to find delta. Given I have been given epsilon, to find delta. What will be the value of delta with in terms of epsilon? In terms of epsilon, let us first solve this part. So see, 3x minus 3 is less than epsilon. From here, I can say, from here, 3 into x minus 1 mod is less than epsilon. Now you know that AB mod is equal to mod A mod B. Mod A mod B. Wait, let me rewrite. It is equal to mod A mod B. So now this is A and this whole is B. So this can be now written as mod 3 mod x minus 1 and less than epsilon. And you know what is mod 3? Mod 3 is 3. So this will give me 3 mod x minus 1 less than epsilon. So x minus 1, this 3 you divide both sides. Divide the whole equation by 3. So you will get epsilon by 3. Now compare this line and compare this. So compare this and compare this. See, both are looking same, only now delta is this. So taking delta equal to epsilon by 3, delta equal to epsilon, मुझे I had to find this delta, मुझे ये delta ही ढूंढना था, ये प्रोसेस करके डेल्टा मुझे मिल गया. So I got the delta. So now I can say when taking delta equal to 3, we have this fx minus L is less than epsilon, taking this whenever. So I can write this thing here. Wait, let me write it here fully. Let me write this thing here. 3x plus 1 minus 4 is less than epsilon whenever x minus 1 is less than delta equal to epsilon by 3. This is the way you have to write. How to write? Whenever. Wait. This is whenever. Wait. Whenever. This is the way you have to write. I'll do one or two more questions in this so that you are aware of how to get over it. Now let's take another example. Let's take another example. Question. Show that this limit x tending to a x square minus a square upon x minus a is equal to 2a. Now compare again. फिर से compare करो rough में. Limit x tending to a fx equal to L. So what is my fx? Answer. fx is x square minus a square upon 2a, x minus a. Then your L is 2a and a is a, of course. There's no problem about it. So now you write down fx minus L is less than epsilon whenever, wait a minute, whenever x minus a is less than delta. This is the definition. You have to always write this definition. ये definition ये बार-बार लिखना पड़ेगा. Now, just a minute. Now, Yes, this is our problem. Yes, now see, put in the place of x square minus a square upon x minus a minus what is L? L is what? 2a. 2a mod is less than epsilon whenever, just a minute, let me rub this line. Yes. Now, whenever x minus a is less than delta, मुझे ये डेल्टा ढूंढना है, एप्सिलॉन दिया हुआ है मुझे. What I can do, start from here now. Start from here. This a square minus b square can be written as x minus a and x plus a upon x minus a minus 2a mod whole mod less than epsilon. Now this and this cancels out. This and this cancels out. Let's drag it down. Let's take a little more page. Yes. Now what you have is mod. You have this mod x minus plus a minus 2a is less than epsilon. That means this will give me x minus a less than epsilon. Now check this. This and this. So delta is equal to epsilon. So I have to taking, देखो यहाँ पे जैसे जिस फॉर्मेट में ये द सेम फॉर्मेट, दे आर इन द सेम फॉर्मेट. सो नाउ यू टेक डेल्टा इक्वल टू एप्सिलॉन, टेकिंग डेल्टा इक्वल टू एप्सिलॉन. सो योर दिस x square minus a square upon x minus a minus 2a is less than epsilon whenever x minus a is less than delta equal to epsilon. So done. This question is done. Let's do another question on this. Let's do another question on this. Let us do some more question on this. Let me do one more question. That would be more clear. Wait. Okay. Let us do this question. Do this question. Let us do this question. You have no. You. I won't do it yourself. Homework question. This is for your homework. Limit. Show that. Wait a minute. This is your homework. Show that. Show that. Show that. Show that. Show that this limit extending to 2, 2x plus 5 is equal to 9. You have to show me this. You have to tell me. So my here, what should be, that means यहाँ पे दिखाना है तुमको कि ये लिमिट एग्जिस्ट करता है तो कैसे, व्हाट इज द रिलेशन बिटवीन डेल्टा. डेल्टा इज हाउ मच ऑफ एप्सिलॉन. आई एम गिविंग यू द आंसर हियर, you should get the answer. I'm giving you the answer. It is epsilon by 2. You have to show me that this delta is epsilon by 2. Exactly the way I did it. This is your homework. Now come to another situation. Before I start a situation, let me tell you a very, very important concept. Very, very important concept. Important concept. Remember, limit x tending to 0 plus sine 1 upon x is always plus 1. And limit x tending to 0 minus sine 1 upon x is equal to minus 1. This I may put in a proper color box. Wait, let me put it in this box. This is a very, very important concept and you need to keep in mind. Let's do a problem on this concept. Let's do a problem. इस concept पे एक problem करते हैं. This is 1 actually. This is 1. Fine. Now let's do a problem. Let's do a problem. अच्छा अब ये यू में आस्क कि कौन कब ये लिमिट ये वाला कॉन्सेप्ट यूज करना कब, वो बोल देंगे क्लासिकल डेफिनेशन, फॉर्मल डेफिनेशन, शो बाय यूजिंग फॉर्मल डेफिनेशन और क्लासिकल डेफिनेशन दे विल से, देन यू डू दैट वे. नाउ क्वेश्चन, लिमिट evaluate 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 limit x tending to 0 sine 1 upon x. This they have asked. So you write straight away RHL. You write RHL, limit x tending to 0 sine 1 upon x goes to 1 and plus 0 plus, and LHL, you have limit x tending to 0 minus sine 1 upon x goes to minus 1. So limit does not exist. So limit, since right hand side limit x tending to 0 plus fx is not equal to limit x tending to 0 minus fx. So limit x tending to 0 sine 1 upon x does not exist, does not exist, does not exist. This is done. Now take one other question. Now see this. Show that question, show that limit x tending to 0 x sine 1 upon x is equal to 0. Let me tell you one thing here. Note, very important note. Sine x is always, I told you also, sine x is always between my plus 1 and minus 1. And I've told you in the graph also, mod of sine x is less than equal to 1. So whatever you have this x as, you may have apples, sine apples, whatever you have here in place of x. I mean to say, in place of x, if you have a sine upon x and mod, this is always less than 1, less than equal to 1. This is always, because, and similarly is the case for cos also. So now let us do this question. Now we have comparing again, fx comes out to be x sine upon x, x x sine upon x. My L is 0 and my A is also 0 if I compare. Now let us use the classical definition to show this. Classical, I don't need to show right hand. I can do this with right hand, left hand also, or I can do it this way also. I'll show you how to do it in both ways. Number one method. Fx minus L is less than epsilon whenever, when, wait a minute, let me rub it. Whenever, whenever x minus a is less than delta. So here fx is x sine 1 upon x minus 0 is less than epsilon whenever x minus 0 is less than delta. Basically this means x sine 1 upon x, because you're subtracting with 0, 0 subtract करोगे तो वही मिलेगा. You will, if you subtract something with 0, you will get that only. Whenever mod x is less than delta. Now we will do the things. Now I have to see, epsilon is given to me. How my delta will be? Let me check. I've got here. Now I told you a mod, b mod is a mod sine 1 upon x mod. Now this quantity is, see, this is the way I've written it. Instead of writing this way, let me start with this. Basically, this will come to this. So this will be, just a minute, let me rub. This will be less than mod x. How? See, I just told you sine mod x is less than equal to 1. Now there is a mod x here. Multiply both sides by mod x. Mod x sine 1 by x, and then you will have mod x. Therefore this. And this quantity is less than epsilon. This quantity is less than epsilon. So taking, this is the reason. You can write this reason, since taking delta equal to epsilon. So we have x sine 1 upon x minus 0 less than epsilon whenever x minus 0 less than delta equal to epsilon. This is the one method of doing this problem. The other method, see, method number 2. Now limit, you had x tending to 0, x sine 1 upon x equal to 0. Take RHL. Limit x tending to 0 plus x sine 1 upon x is equal to limit x tending to 0 plus x into, I'll tell you right now the properties of limit. Hold on, because this is possible. You can take limit x tending to 0 plus sine 1 upon x. This comes out to be 0 into 1. You get 0. Now the LHL. Now the LHL part is, LHL, the left hand limit x tending to 0 minus x sine 1 upon x, limit x tending to 0 minus, x into limit x tending to 0 minus sine 1 upon x. This is equal to 0 into minus 1. As I told you, it will be 0. So both the limits are same. Therefore, limit x tending to 0 plus x sine 1 upon x is equal to limit x tending to 0 minus x sine of 1 upon x is equal to, so limit x tending to 0, x sine 1 upon x sine 1 upon x exists. So exists, we write it down. So it exists. So it exists, and limit x tending to 0, x sine 1 upon x is equal to 0. This is the way. I hope now you're getting the idea clear. Let us do one more question like this. Let us do this question now. See, evaluate question. Evaluate, limit x tending to 0 under root of 1 minus cos 2x upon under root 2 x. I have earlier given you the formula of cos 2x, all the formulas, so I'm not telling, because this is a minus, you will use the plus formula. That means you will use cos 2x is equal to 2, you will use 1 minus 2 sine square x. 2 sine square x, you will use this formula because there is the minus. And if it is a plus sign, then 2 cos square x plus 1. Remember that one. So here we will use it. Let's use it. First, let us try to solve this question. Now, evaluate, they have said. So first, let us answer. This is the way you will do it. Limit x tending to 0. You will not start with left and right now. First, you will try to bring it in proper shape. 1 minus 2 sine square x upon under root 2 x. This is equal to, now see, limit x tending to 0. 1 and this one will cancel out, and this minus will make it plus. So you get under root 2 sine square x under root upon under root 2x. Cancel this out. Now, at 0 plus and 0 minus, there will be a problem with plus and minus sign. So we have to take, so this under root 2, this will be, see, you will always get a positive, you always want a positive value for this. You will always take a positive value. Therefore, you will write limit x tending to 0. See, under root of x square is what? Basically x only. But if you always want a positive value, you have to write like this. अगर देखो अंडर रूट ऑफ एक्स स्क्वायर क्या होता है? x होता है, प्लस माइनस x होता है. मुझे हर समय प्लस आंसर चाहिए, तो दिस मॉड x. ऐसे भी देखो अंडर रूट एक्स स्क्वायर क्या होता है? प्लस माइनस x. और मॉड x भी क्या होता है? एक बार x, एक बार माइनस x. दिस, इफ यू ऑलवेज वांट अ पॉजिटिव वैल्यू, so you need to take mod. Because of this reasoning, wait a minute, let's rub all this. So now the point is here, mod sine x upon x, mod sine x upon x. Now we will start from here. Now we will start, see how to start. First we will come to this, पहले हम इसको इसमें convert करके लेके आएंगे. अब देखो, now let me take the question. Yes, this much only I need, that's the thing. Now LHL, limit x tending to 0 minus mod sine x upon x. So limit h tending to 0 sine 0 minus h mod upon 0 minus h. This is equal to limit h tending to 0. 0 minus h is sine minus h mod, and 0 minus h is minus h. अब देखो sine minus theta, sine minus theta is minus sine theta. You have to keep this thing in mind. I told you in my earlier video. Cos minus theta is cos theta. Keep always this in mind. Tan minus theta is now minus tan theta. Keep this thing in your mind. Okay? So using this, let me rub this now. So using this, so I will get, this is equal to limit h tending to 0 sine minus h mod and upon minus h, and this is this is equal to limit h tending to 0. This is your sin h upon minus h, and you will get minus outside. Limit h tending to 0, sin h upon h is equal to 1. Later on, I'll tell you. Right now, you take this definition. Later on, this is a formula also. Limit x tending to 0, sin x upon x equal to 1. Here it is h and h, so it is 1. Fine. So minus 1, sorry. This is minus 1. This is minus 1. This is minus 1. Now, let us find the right hand limit. Right hand limit. I forgot this minus sign here. Now RHL. Now see, you have RHL. You have RHL. You have RHL. RHL. You have limit x tending to 0 plus mod sin x upon x, limit h tending to 0. This is sin 0 plus h mod upon 0 plus h. So this will come out to be straight limit sin h mod upon limit h tending to 0 upon h, and this will h, this is h, this is h, this is h, and now you have equal to limit h tending to 0 sin h upon h, and this is equal to plus 1. I got plus 1 here, I got minus 1 here. Therefore, limit x tending to 0, see, let's write this. Limit x tending to 0 plus fx is not equal to limit x tending to 0 minus fx. So, limit x tending to 0 under root 1 minus cos 2x upon under root 2x does not exist. Does not exist. Does not exist. Does not exist. Next is the question. Now take evaluate. First, before that, I'll give you the properties of limit. Wait. Now, properties of limit. Properties of limit. Limit. First is this. Number one property. This is limit. Number one. Here it is. Number one. Number one is limit x tending to a fx plus gx would give me limit x tending to a fx plus limit x tending to a gx. And if it is a minus sign, then you will have to put a minus sign here. Next, second, limit x tending to a fx into gx. So this will be limit x tending to a fx into limit x tending to a gx. Third one, the third one is limit x tending to a fx by gx is equal to limit x tending to a fx upon limit x tending to a gx, where limit x tending to a gx is never equal to 0. Now limit x tending to a of a composite function, this f comes out, limit goes inside, limit x tending to a gx. So, and now if limit x tending to a fx to the power of gx, you will have limit x tending to a fx and to the power of limit x tending to a gx. Now let us do some methods on, let us do some problems on different types. The first type is direct substitution. The direct substitution, let us do questions on that. Suppose I have number one, first method is direct substitution. Direct substitution. Substitution. Example, let us take a problem. The question is limit x tending to 0 under root of 5 plus x plus under root of 5 minus x upon 5 plus x. See, if I put 0 here and I put 0 here and I put 0 here, nothing happens. It is under root 5 plus under root 5 upon 5. So you can directly put the 0. So under root 5 plus 0 plus under root 5 minus 0 upon 5 plus 0. This is nothing but under root 5 plus under root 5 by 5. This is 2 under root 5 by 5.